Hello and welcome to a new video on IGCSE Physics Classified Paper 4. In this video, we shall be discussing density. We will begin with conceptual questions. Figure 3.1 shows an oil tank that has a rectangular base of dimensions 2.4 by 1.5. The tank is filled with oil of density 850 to a depth of 1.5. In question C, we are told when he is checking the level of oil in the tank, a man drops a brass key into the oil and it sinks to the bottom of the oil. States what this shows about the density of brass. So this shows that brass is denser than oil. This is the simple answer to this question because the brass key sinks. So therefore, since the key sinks in the oil, then the key is denser than the oil. And the key is made of brass, so we can say that brass is denser than oil. In double I, we are told, explain how attaching the key to a piece of wood could prevent the key from sinking. So the idea is that when you attach the key to the wood, they become one body, they become a single entity, and wood is less dense. Of course, it's much less dense than brass. So the combined density of brass and wood would be less than the oil. Therefore, the whole body as one unit would float, not sink. Figure 2.1 shows a hollow metal cylinder containing air floating in the sea. The density of the metal used to make the cylinder is greater than the density of the seawater. Explain why the cylinder floats. So if the cylinder floats, the first intuitive assumption is that the cylinder is less dense than the liquid. But that's not what they're saying. They're saying the density of the metal is greater than the density of seawater. So how is it that the cylinder floats? This is because the cylinder is not made completely of metal, since it's a hollow metal cylinder. So this means that we have a lot of air inside. So since it's not a solid cylinder, it's a hollow cylinder, it's free from the inside. So the combined density of the cylinder and the air make it less dense than the seawater. Next, we move on to calculation problems. A rectangular container has a base of dimensions 0.12 times 0.16. The container is filled with a liquid. The mass of the liquid in the container is 4.8 kilograms. The depth of liquid in the container is 0.32. Calculate the density of the liquid. So the rule for density is rho equals m over v. In words, that could be written as density equals mass divided by volume. So here we are not given the volume directly. We're given that it's a rectangular container, so it's like a cuboid. And the volume of a cuboid is length multiplied by width multiplied by height. So to get the volume of the container, we multiply the length and the width and the height. So the volume would be 0.12 times 0.16 times 0.32. And we already have the mass. So the density becomes mass over volume equals 4.8 kilograms divided by the volume that we obtained above, which is 0.12 times 0.16 times 0.32. And you can evaluate this using the calculator. And this is the answer that you would arrive at. Of course, we approximate to three significant figures. So 781.25, you can approximate it as 780 or 781, two or three significant figures. That would be okay. The equipment releases a balloon from a point that is a small distance above the surface of the planet. The atmosphere at the surface has a density of 0.35. The inflated balloon has a mass of 80 grams and a volume of 0.3 meter cube. Make an appropriate calculation and then predict and explain the direction of any motion of the balloon. So when we have density problems, we're usually asked about whether something is going to sink or float. So in air, it doesn't really sink and float because it's not a liquid. So it moves up or down. So we have a balloon in an atmosphere in a different planet, and the density of the balloon determines whether the balloon will fall or rise up. If the density of the balloon is less than the density of the atmosphere, it will rise up. If it's more dense than the atmosphere, it will fall down. So what is the density of the balloon? Again, we apply the same equation, mass over volume. And here we are given the mass, but the mass here is 80 grams, and we want the unit to be in kilograms to compare, since the other density is given in kilograms. So we convert the 80 grams to kilograms by dividing by 1,000. And when we divide by 1,000, we get 0.08 kilograms for the mass. So now that we have the mass, we just divide it by the volume as such, and we get 0.267 kilograms per meter cubed. Now we compare this to the density of the atmosphere, and since this is less dense than the atmosphere, therefore it will float up or rise up. A block of wood has a volume of 210 centimeters cubed and a mass of 180 grams. Calculate the density of the block of wood. Again, this is easy. Density is mass over volume. Now, why did we not convert to kilogram here? Because we're not obliged. There is no other quantity given in kilograms. So we can just use grams as long as we write the final answer in grams per centimeter cube. So when we're writing the unit for density, it could be kilogram over centimeter cubed or gram over centimeter cubed. So here we just use the given units. We don't do any conversions, and we just write 180 divided 210, and we find the answer, and we write the units as they are, just the grams and the centimeter cubed given in the question. The block is held just above the surface of a liquid of density 0.88. Predict and explain what happens when the block is released. Of course, since the liquid is more dense, it's going to float, since the density of the wood is less than the density of the liquid. A scientist fills a container with seawater. The container has dimensions 30 centimeters by 30 centimeters by 40 centimeters. The density of seawater is 1,020. Calculate the mass of the seawater in the container. So again, you have to notice the units. The density here is given in meter cubed, and the dimensions are given in centimeters. So here we have to convert from centimeters to meters so that we have the same unit. So we just divide by 100. So to go from centimeters to meters, you just divide by 100. This becomes 0.3, this becomes 0.3, and this becomes 0.4. And I would like you to be able to play around with the equation as much as possible. What does that mean? So the equation that we are familiar with is density equals mass over volume. In symbols, it is rho equals m over v. So this can be rewritten as m equals rho v. If you send the volume to the other side by multiplication, it becomes m equals rho v. So since we are looking for m here, it's easier to write the equation in this format so that we can calculate m immediately. So we want the mass. Mass is density times volume, and we are given the density. We take it as it is. But for the volume, like we said before, we have to convert the units into meters. And once we have all the dimensions written down, we multiply everything and we get the final value for the mass. Of course, 36.72 can approximate to 37. A student wishes to find the volume of a piece of wood of irregular shape. Her experiment requires the use of a small brass object of mass 200 grams. Calculate the volume of the brass object. given that the density is 8.4 grams per centimeters cubed. We notice here that the density is given in grams and the mass is given in grams. So there will be no need to convert the unit of the mass into kilogram in this question. We're going to use the values as they are. So we have 200 for the mass, 8.4 for the density, and we use the equation and find the value of V. Again, you will notice that this is not the original equation that we are used to. We have rho equals m over V, but we can convert that into V equals m over rho because you simply switch the values of these two variables. So this is a mathematical issue. Let me just outline it very briefly here. C equals A times B, B equals C over A equals C over B. These are all the same equation written in different forms. So just in the same manner, if the mass equals the density times the volume, the density is mass over volume, and the volume is mass over density. You can write the same equation in either one of these three forms, as long as you write it correctly, so that you can get the variable that you need. So if we want the volume, this would be the best form of the equation to use. So volume is mass over density, and therefore the volume is 200 over 8.4, and we can get the 24. In B, we are told to find the volume of the piece of wood. The student has a measuring cylinder, a supply of water, and the brass object in A. The piece of wood and the brass object are small enough to be placed in the measuring cylinder. The piece of wood does not sink in water. Suggest why? Obviously, because the wood is less dense than the water. In double I, we are required to describe what the student does to find the volume of the piece of wood, stating the measurements that she makes and any calculations required. So let's retell what the problem is. We want to find the volume of a piece of wood, and we have a measuring cylinder, and we have a piece of wood attached to a brass object. And the reason we're attaching it to the brass object is we want it to sink inside the cylinder because the wood alone is not dense enough to sink. So we're attaching it to a brass object so that it would sink inside the measuring cylinder. So that would be the first step. We would tie the wood to the brass so that it would sink in the water. And then we first pour water into the cylinder. So this is called the displacement method, or it's a method or an experiment to measure the volume of an irregular object. We have a measuring cylinder. We first pour water up to a certain height or a certain level. And we know that this is the volume of the liquid because the measuring cylinder automatically gives us the volume of the liquid. Let's call that V1. And then we sink the object, the brass and wood, into the cylinder, and we see the new level of water, and we measure that as V2. So that's what we wrote here. We pour water and measure the initial volume V1. We put the brass and the wood to find V2. Now, if we subtract V2 minus V1, this gives us the difference in volume caused by this box over here. So therefore, V2 minus V1 is equal to the volume of the box. What is the box? The box is the combination of brass and wood. We only want the volume of the wood. So after subtracting, to get the volume of the brass and wood together, we subtract the volume of the brass that we already found in order to get the volume of the wood. The volume of the brass was found in question 8, it's equal to 24 centimeters cubed. So we just subtract that from the answer, and that gets us the volume of the wood. A student has 500 identical rectangular sheets of paper. The mass of 1 meter squared of the paper is 0.08 kilograms. Using a meter rule, she measures the length of one sheet of paper and its width. The length is 0.3 and the width is 0.21 meters. Calculate the mass of one sheet of paper. So how would we calculate the mass? We already have a ratio here the mass of 1 meter squared of the paper is 0.08 kilograms. So we already have a ratio between area and mass. Since meter squared is the unit for area, so we know that the area here is 1 and the mass is 0.08. Now we want the mass of one sheet of paper, so we want M, given that this sheet of paper has a length of 0.3 and a width of 0.21. So you can get the area of this paper by multiplying 0.3 by 0.21, and that gives you 0.63. So you just write that down in here and you cross multiply in order to find M. So therefore, the mass would simply be 0.08 multiplied by 0.063. Excuse me, I made a small mistake. This is 0.063, not 0.63. I apologize for that. So 0.08 times 0.063 gives us 0.00504 kilograms. The student makes a single pile of the 500 sheets of paper. With a meter rule, she measures the height of the pile. The height of the pile is 0.048. Calculate the density. So since we want the density, we remember the rule for density, which is rho equals m over v. We already have the mass. Since we have the mass of one sheet of paper, we can get the mass of 500 sheets of paper. So the mass would be the mass we obtained multiplied by 500. And then the volume would be the area given, which is 0.063, which we also calculated in I, multiplied by the height, and the height is 0.048. And then you simply divide the result of the mass by the result of the volume, and that gets you 833 kilograms per meter cubed. Question B says, a second student has only 5 sheets of the same type of paper. Suggest how the student determines the density of the paper to a similar accuracy. Additional apparatus may be used. So the problem with 5 sheets of paper is that you cannot use a ruler to measure the height. So the student in II, she measures the height of the pile with a meter rule. This is what is said in the problem. But we cannot do that if we only have 5 sheets. It would be inaccurate. So instead of the meter rule, we're going to use a micrometer to measure the height of the 5 sheets. And we would also repeat the measurement multiple times and take the average in order to obtain better accuracy. An ice hockey rink has an area of 1,800 meters squared. The ice has a thickness of 0.025. The density of ice is 920 kilograms per meter cubed. Calculate the mass of the ice on the rink. So this is simple enough. In order to get the mass, we remember that rho equals m over v. Therefore, m equals rho times v. So we need to multiply the density by the volume. The density is already given as 920, and the volume is not given directly, but we have the area and the height. So you should always remember the rule volume equals base area times height. We use that in physics a lot. So the base area is 1,800 and the height is 0.025. So we simply multiply these 3 numbers together and we get the mass. So let me erase my work so that we can check the final answer. We get 920, the density multiplied by the base area and the height, 1,800 and 0.025. And the final answer is 41,400 kilograms. We can use 2 significant figures only, so this becomes 41,000 kilograms. All the sides of a plastic cube are 8 centimeters long. Figure 3.1 shows the cube. The mass of the cube is 0.44 kilograms. Explain what is meant by mass. So explain what is meant by mass. This is very important. You need to know what the definition of mass is. There are 2 definitions for mass. The first definition is it's the amount of matter in an object. The second definition is it's the ability to resist change in motion. You can also use measure of inertia. Measure of inertia is basically the same as the ability to resist change in motion. The heavier an object is, the harder it is to move the object. So mass measures the ability to resist change in the motion of an object. In BI, we are told calculate the density of the plastic from which the cube is made. So the density is mass over volume, and we divide the mass, 0.44 kilograms, by the volume, which is 0.08 to the power of 3, and that gives us 860 kilograms per meter cubed. The density of one type of oil is 850 kilograms per meter cubed. State and explain whether the cube floats or sinks. Of course, the density of the cube is 860, so it's larger than the density of oil. As you can tell here, the density of the cube was calculated, and we are given the density of oil, so this is the larger value. So therefore, the cube sinks in the oil. Figure 1.1 shows a cylinder made from copper of density 9,000. The volume of the cylinder is 75. Calculate the mass of the cylinder. So again, this is very simple. We use the equation mass equals density times volume. However, remember the units. So we are given the volume in centimeters cubed, but we are given the density in meters cubed. So we have to convert the volume to meters cubed. Now, 1 centimeter goes to 1 meter after division by 100. So 1 centimeters cubed goes to 1 meter cubed after division by 100 to the power of 3. So to go from 1 centimeter cubed to 1 meter cubed, you have to divide by 100 power 3, which is basically 1 million. So therefore, 75 centimeters cubed would become 75 divided by 1 million meters cubed. So this would be the actual volume. And then we would multiply that by the density. So we have 9,000. So the mass is equal to rho times V. The density is 9,000. And the volume is 75 over 1 million. And we multiply those out together. And that gives us 0.68 kilograms. In question B, we are told the gravitational field strength is 10 newtons per kilogram. Calculate the weight of the cylinder. So you should know that the weight of the cylinder is equal to mass times gravity. And the mass of the cylinder was already calculated as 0.68. And gravity is the gravitational field strength, which is given here as 10. So you multiply them together and you get 6.8 newtons. State one way in which weight differs from mass. Of course, the main difference between mass and weight is that mass is a scalar quantity with no direction, but weight is a vector quantity because it is one type of force, and force has a direction. So it's a vector quantity. Figure 2.1 shows a measuring cylinder that contains a colored liquid. The measuring cylinder contains 82 centimeters cubed of the liquid. The density is 950. Calculate the mass. This is quite simple and straightforward. Mass equals density times volume. And here, again, we have the problem of the units. The unit here is centimeters cubed, but the unit of the density is meter cubed. So therefore, you have to convert 82 to meters cubed, so you have to divide it by 100 to the power of 3, which means we have 82 over 1 million, or 10 to the power of 6, as written here. And then we just multiply these out, and we get 0.0779 kilograms. Now, for C, we're told a small object is made of steel. It is placed level with the top surface of the liquid in the measuring cylinder and then released. The object sinks in this liquid. Explain why the object sinks in this liquid. Of course, because the steel is denser than the liquid. Describe how the volume of the object can now be determined. by measuring the change in volume of the liquid after the object sinks. So what does that mean? We solved a similar question earlier in this video. So the current volume is around 82. After putting in the object, the new volume, for example, becomes 94 or whatever. So to get the volume of the object, we simply subtract 94 minus 82. So the new reading, whatever that is, I just created this value. This is not a correct value. Whatever the value is, we subtract 82 from that value, and the difference is the volume of the object. So we measure the change in volume of the liquid after the object sinks, which is the new reading minus the original 82. Next, we move on to some geometry problems. So in this case, we just need to use a couple of rules from geometry and mathematics in order to find, for example, the volume of an object or something. So the depth of the liquid is 10 centimeters and the radius of the cylinder is 3 centimeters. The weight of the liquid is 2.5 newtons. Calculate the density of the liquid. So this question is a bit challenging compared to previous questions because it's not very direct. We have density equals mass over volume. So to get density, we need mass and we need volume. Now we're told that the weight is 2.5, and we should know that W equals mg. So therefore, 2.5 equals m multiplied by g, which is 10. Gravity is always 10, or 9.8 if you want to be very accurate. So the mass is 2.5 divided by 10, which is 0.25. Hence, the mass of the liquid is 0.25 kilograms. And the volume of the liquid is unknown. However, we are given the length and the radius. So the radius of the cylinder is 3, and the depth of the liquid is 10 centimeters. We can work with centimeters here because we can just write the final answer in centimeters since we're not given a specific density with a specific unit. So we don't need to do any conversions. But you should remember that the volume is equal to base area multiplied by height. The height of the cylinder is the depth of the liquid. So this is just 10. We're already given that. But the base area is actually pi r squared. And we are given the value of the radius. So pi times 3 squared times 10. And that gives us the answer for the volume. So let's check the answer to the calculations. Like we said, the mass here is 0.25 because it's weight divided by 10. And the volume is pi r squared h. So pi times 0.03 squared times 0.1. Like we said before, we don't have to do the conversion. We could have just written 3 and 10 and obtained the answer in centimeters cubed. That would have worked as well. However, it's okay to convert as well. So we converted here and we got the answer as 890 kilograms per meter cubed. Figure 2.1 shows the liquid in a cylinder. Table 2.1 gives some data about the cylinder and the liquid. The cylinder containing liquid is placed on a digital balance that displays the mass in kilograms. Calculate the reading shown on the balance. So in order to calculate the reading shown on the balance, we need to figure out a couple of things. So what is the reading on the balance? What does that consist of? So it consists of two things. It consists of the weight of the empty cylinder plus the weight of the container. However, since the balance displays the mass, not the weight, so we have to divide by 10. So for example, the weight of the container, instead of 2.5 newtons, this is going to be 0.25 kilograms. How did we get that? Because weight is equal to mass times gravity. So 2.5 equals mass times 10. So mass equals 2.5 over 10, which is 0.25. Therefore, the mass of the empty cylinder is 0.25 kilograms. This is the mass of the container. Next, we want to get the mass of the liquid. So how do we get the mass of the liquid? We are given the density and the radius and the depth. So these are similar to the previous problem. So the mass of the liquid is how much? It's equal to the density times the volume. The density is already given as 900 and it's given in meter cube. So we have to use meters in our units. So therefore, we convert this to 0.035 meters, and we convert this to 0.12 meters. And we plug into the equation of the volume, which is base area times height. Base area of a cylinder is pi r squared, and the height is simply h. Of course, pi r squared would just be, as you can see in the written answer here, it would just be pi times 0.035 all squared, and the height would be 0.12, and we would multiply these out to get the volume, and then we multiply the density by the volume we obtained, and that gives us the mass of the liquid. Now that we have the mass of the container and the mass of the liquid, we simply add them up, and we get the final answer as 0.66 kilograms. So to recap, the balance is going to show the complete and total mass. So this is equal to the mass of the empty cylinder, which is this guy divided by 10, so 0.25, plus the mass of the liquid, which is density times volume, and we calculate the volume of the cylinder as pi r squared h, and we make sure that these are given in meters. This is the summary of the problem. Figure 1.1 is the top view of a tank in an aquarium. The tank is filled with salt water. The depth of the water in the tank is 2 meters. Calculate the volume of the water in the tank. So to get the volume, again, we should know that this is equal to base area times height. So we need to get the base area since we already know the height. The height is 2. How do we get the base area? So this is a weird shape. It's not a regular shape. So in order to get the area of this shape, we need to split it into different sections such that we can get the area of each section. And this is what I'm going to do right now. So we split the shape into 2 different sections. And then the area of this shape here would just be 1 times 3.2. And the area here would be 1.1 times 1.6. And then once we get that, we simply add them up. We add area 1 and area 2 together, and that gives us the total area of the shape. So therefore, the area is 1.1 times 1.6 plus 1 times 3.2. That gives us 4.96. And then we use the rule that says volume equals base area times height. This is the base area, and this is the height. So therefore, we get 4.96 times 2, which is 9.92. The density of the water in the tank is 1.1 times 10 to the power of 3. Calculate the mass of the water in the tank. So to get the mass of the water in the tank, we use M equals rho V. We already have the volume, and the mass, and the density is already given in the problem. So we multiply them out, and we get the mass. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.